Hi, welcome to the Center of Math's Thanksgiving-themed problem of the week. This week our problem is a large Thanksgiving banquet served between 500 and 600 people. The dinner rolls came in baker's dozens. After everyone had been served a roll, there were a number of empty packages plus one open package with 10 rolls left. The pies for dessert had been cut into ninths, and after everyone had been served a slice, there were a number of empty pie tins plus one pie tin with 4 slices left. The tables in the banquet hall each had room for 15 guests. All but one of the tables were full. How many people were seated at the last table? All right, this problem we have a lot of unknowns, so we're just going to assign a variable for each unknown. We'll let x equal the number of guests, r equal the number of empty packages of rolls, p is the number of empty pie tins, c is the number of chairs used at the last table, and t will be the number of tables used. And we can write, using these variables, we can write the number of guests used in terms of the rolls, the pie tins, and the tables. Baker's dozen comes in pack, so that means it comes in a package of 13. So we have the number of guests is equal to the number of packages of rolls r times 13, and there's one package with 10 left over, which means there were 3 rolls consumed. And then in terms of pie, there's cut into ninths, and then there was one package with 4 slices left over, which means 5 pieces were consumed. And then for the tables, 15 people can be seated at each table, and then we don't know, this is what we're solving for, is how many people were seated at the last table. And we also know that there were between 500 and 600 guests, so we can write these as inequalities. So 13r plus 3 has to be between 516, and 9p plus 5 is also between 516, and we'll just solve for r and p. So we'll subtract 3 from both sides, and then divide both sides by 13, and you have that r is between 38.23 and 45.92, but the number of packages of rolls has to be a whole number, so we'll say that r is between 39 and 45. And then for p, the same thing, subtract 5 from both sides and divide both sides by 9 to see that p is between 55 and 66.11. And once again, the number of pies consumed have to be whole numbers, so p is between 55 and 66. So from here, you can do 2 things. You can plug in possible values of r and possible values of p into the equation to solve for x and see when x is the same for both. Or you can plug in possible values of r to solve for x, and we know that x is equal to 9p plus 5. So if we solve x minus 5 and see when it's divisible by 9, then we'll have our answer, which is what we're going to do. The way we set this table up is we have possible values of r, which we got from our inequality, and then we're going to solve for x, 13r plus 3, and then we'll do x minus 5, and if that's divisible by 9, then we found p because x is equal to 9p plus 5. So first value, 39, you get x is 510, x minus 5 is 505, and that's not divisible by 9. Same thing for 40, that's not, when you solve for x minus 5, it's not divisible by 9. And then we get to r is 41, so x is 536, x minus 5 is 531, and this is divisible by 9. So we don't need to continue on and test the other ones because we found our answer. We have the number of empty packages of rolls is 41. The number of guests, which is x, is 536. And then we have the number of empty pie tins is 59. We still need to find how many people were seated at the last table. In the beginning, we said that x is equal to 15t plus c. And we just found x, 536. So we'll divide it by 15 and see what the remainder is. The 536 divided by 15 is 35 with a remainder of 11. So there were 35 full tables and 11 people seated at the last table. Thank you for watching. I hope you enjoyed this video. We wish you a happy Thanksgiving. Be sure to check out our Facebook, follow us on Twitter, and check out centerofmath.org. Thank you.